All right, so we are starting Unit 8, and Unit 8 is all about applying integration. And this first lesson is about finding the average value of a function. So we're going to use integrals to find the average value. All right, and so I have a little joke up there if you want to read it. It's kind of funny, I don't know. All right, so the temperature T in degrees Celsius recorded during a day followed that curve where T, lowercase t, is the number of hours from noon. So negative 12 would be midnight on the first, at the beginning of the day, and positive 12 would be midnight at the end of the day. All right, so what we're going to do first is shade the region under the curve above the t-axis between negative 12 and 12. Okay, so that's halfway decent. All right, and then for B, we are going to draw one rectangle over that interval from negative 12 to 12 that has the same area as the shaded region. So I want the sides of the rectangle to actually be at negative 12 and 12. Right, and then we want to figure out a height of that rectangle so the area of that whole rectangle matches the purple area. So I would say about 15. That's a pretty good height. So if you think about this area at the top, filling in spaces here and here, I think it would be close to filling it in. Okay. So then we did B. For C, the height of this rectangle represents the average temperature during the day. If the area is matched, that would be true. We want to find what's the height of our rectangle? The one I drew, the height is 15 degrees Celsius. So that matches up with the average temperature if the areas match up. All right. Then for D, we're going to think about what we would do to find the area of our rectangle. So it's going to be the height of 15. And to find the width, we would do 12 minus negative 12. I'm writing it that way for a specific purpose, but that is what you would do. We'll find that in just a second. All right, and then for E, how do you find the area of the shaded region, the area under that curve on the interval from negative 12 to 12? And there's a hint that we do need to use calculus. So anytime we're finding the area under the curve, we are finding the integral from negative 12 to 12 of that t function with respect to time. So that's why we have the dt with the lowercase t. Okay, and we're going to use our calculator to see how close I guessed. And you guys might have guessed a different one, so you can use your guess if you want to. But for the rectangle, it's going to end up being 15 times 24, which is 360. For the actual area, it's going to be the integral from negative 12 to 12. And I'm just going to go ahead and write in the function. Okay, so we'll go to the calculator and figure that out. Okay, so I guess pretty close. Now, if you guess perfectly, obviously that would match exactly with the average temperature would match exactly with that integral value. Okay, so for G, this is the whole point, so we can do this G problem. Write the equation to represent this relationship. We're going to use the following labels. So our average temp, which was 15, we're going to call that T average. All right, and then for negative 12, we're going to call that A, and for 12, we're going to call that B. All right, so that little blue, I'm changing to T average times, and we did B minus A, we did that, should be equal to the integral from A to B of T dt. Okay. Now, what we're wanting to do in this lesson is actually find that T average. So if we solve that equation for T average, we would divide by the B minus A. So that would translate to T average is equal to 1 over B minus A times the integral from A to B of T dt. That's our big formula. All right. So our important idea is that the average value of a continuous function over that interval is equal to exactly what we just wrote. We'll call it F. Oh, that's a weird F. F average is equal to 1 over B minus A times the integral from A to B of f of x dx. Okay. So on example 1, A and B, we are going to find the average value of the function over the interval, and then we're going to find all the values of x in that interval that equal the average value. All right, so we are going to have to do an integral on each of these. So remember that for integration, we don't have a quotient rule, we don't have a product rule, so we cannot find the integral of a quotient or a product. We have to rewrite it in some way. And so for this one, the way we're going to rewrite it is to go ahead and divide each of those, that x squared and the 1, by x squared. So I would rewrite it as 4. Right, and then when I'm going to divide x squared by x squared, and I'm going to divide 1 by x squared. So it's going to be 4 times 1 plus, and then we can't integrate, well, I can't, it's hard to integrate it in your head, 1 over x squared, so we would write it as x to the negative 2. Okay, so we're ready to use our formula. So to find f average, we're going to do 1 over, and then we take our integral, and we subtract b minus a. So this is a, this is b, so it's going to be 3 minus 1 times the integral from 1 to 3 of our function in the form that we can integrate it, dx. Okay. Now, when we have a constant multiplied, we can just bump it out in the front, which is what I'm going to do. So that's going to be 1/2, and then we would multiply that by the 4. All right, and then we're ready to find the integral of, we want to find the integral of 1 plus x to the negative 2, because that 4 is bumped out. So the integral of 1 dx is going to be x, right? And then for x to the negative 2, we add 1 and divide by our new exponent. And then we're going to use the fundamental theorem of calculus to find the definite integral from 1 to 3. All right, so we're still finding F average. 1/2 times 4 is 2, so we'll let that 2 hang out. I'm going to just simplify this a little bit more. All right, so I just changed my sign because I was basically adding a negative. And then x to the -1 is 1 over x. Okay, so I'm ready to plug in. So the first one I would plug in would be 3. It would be 3 minus 1/3. And then minus, and I would plug in 1. Okay. 3 minus 1/3 is 9/3 minus 1/3, which is 8/3. All right, and obviously 1 minus 1 is 0. All right, 2 times 8/3 is 16/3. That is the average value of that function on that interval from 1 to 3. All right, and then we want to know how many times in that interval does the function equal its average value. Okay, so like if we take all the infinite number of values between when x was 1 and when x is 3, divided them by how many there are, we would get this value, which is impossible to do without calculus. So what I want to do now is figure out when in that interval that function actually equals that average value. So I would take the function and I would set it equal to the average value. Okay, and then it's just algebra here. We're just basically solving this by cross multiplying. And then solving it for x. Oh, I wrote it down wrong. Sorry, that's an x squared. So when I solve this equation by taking the square root, we'll do the positive and negative. And we do get positive and negative square root of 3. However, always check your interval. So we need a value between 1 and 3. Obviously, the negative square root of 3 is not in that. So the square root of x equals the square root of 3, positive square root of 3 is the only answer. Because negative square root of 3 is not in the interval from 1 to 3. Okay, we're going to do another one. We're going to do b over here. So for b, our function is the cosine of x, and our interval is from 0 to pi over 2. So don't let the fact that this one has trigonometry make you nervous. We don't have to change the function like we did on the last one. We're ready to go ahead and set up our equation where f average is equal to 1 over b minus a times the integral from a to b of our function, which is 2x dx. Okay, so our f average, that's going to end up being 1 over pi over 2, and we'll make that prettier in just a second. All right, and then the antiderivative over the integral of cosine of x is going to be sine of x. And we need to evaluate that from 0 to pi over 2. I'm not really sure why I did pi over 3 there. Sorry. All right, so then when I have 1 over pi over 2 is the same as 2 over pi. All right, and then I'm going to plug in my pi over 2 and plug in my 0. All right, the sine of pi over 2 is 1, and the sine of 0 is 0. So our average value of that function is going to be equal to 2 over pi. So that's the answer to the first question. All right, then we want to find when in that interval the cosine of x is actually equal to the average value. Now that is not something you can do in your head. You have to use the calculator. So what we'll do for y1, we're going to put in cosine of x. For y2, we're going to put in 2 over pi. And then we're going to look at the window from 0 to pi over 2 on the x. So x min is 0. And then x max is pi over 2. Okay, so let's get all that typed in. Let me make sure I'm in radian mode. Okay. And then I'll go to the window and I just want to go from 0 to pi over 2. Okay. I'm going to change my y because that's hard to see. So let's just go from -2 to 2. Here we go. Okay. So we want to find where they intersect. So we're going to second, trace, and 5. And then just hit enter on each and enter again. So that looks like there's one place in that interval where the cosine of x is actually equal to the average, and that's when x is 0.880 or 0.881, however you want to give your answer, either rounding or truncating. It does not matter. All right. So for your assignment on page 288, I want you to do 51, 54, 55, 59, and 66.